print that like make it something. I thought you said you read the instructions.
I lied. Is there any way I can zoom? It'll have to do. I'll write big. You'll be fine, KJ. Just put your pair of glasses on.
You know what you can do? You can...
Yeah, look, that's fine.
Don't use that word.
There now. We're laughing. Alright. Alright, write these numbers down. Let's see. 4, 2, and 0. And then these numbers here. Yeah, write these down, those 3. And then there's another one to do. -2, 2, and 6. So just to get started, I want the mean average for both, please.
Like, yeah, 2 separate.
2 separate questions, yeah.
Mean average?
For each. So for the first one, the average is 2. And the second one? It's also 2. So these data sets, if we were to picture them on the number line, there's 0, 1, 2, 3, 4, 5, 6, minus 1, 2, 3, 4, 5, 6. So in red is the first one, 0, 2, 4. And then in green is the second one, minus 2, 2, I'll put it rounded, 2, and then 6. So although they both have the same average, if you look at the green one, it's over a bigger space than the red data. So one way you can measure the space is by calculating what's called the range. And the range is the biggest number minus the smallest number. So the range would be 4 and 8. So the range of the green data is 8 and the range of the red data is 4. But this is not the best way to measure how spread out the data is, because if I did something like this, 2, 102, minus 98. This data also has an average of 2, but it's much more spread out, only because the ends are spread out. So imagine I had something like this, hang on, minus 98, 102, and then I had something like 2, 3, 4, 5, 6, 1, 0, minus 1, minus 2. So what's the range of this set of data? What's the range? Check it, yeah?
Two.
200 is the range. Yeah? So the range here is 200. But why is it 200? Only because the first and the last number is so big. Most of the data is not this far away from the average. You can see? They're closer to the average. Let's have a look at how far away each one is from the average. So how far away is 98 from the average? The average is 2. How far away is it?
-6.
No. No. Minus 98 to 2.
100.
It's 100 away. And how far away is minus 2 to 2?
Minus 2.
How far away is minus 2 from 2? 4. And minus 1?
3.
3. And 0?
2.
2. And 1?
0.
And 1?
1, okay.
And 2?
0.
And 3?
1.
1. And 4? 2. And 5?
3.
3. And 6?
4.
4. And 102?
100.
100. So these are how far away these are from the average. I want everybody to average these distances. So you should get something like 2.5. Or 3 even. What did you get? The average here? Come on, hurry up. What's the average of these numbers?
20.
20.
Did you calculate it? No, you didn't. Take out the calculator. Did you calculate it? 20. So why were you sitting there quiet?
Is it 2 point?
It was 2 point something.
I was just guessing. Right, so the average is 20. Now this isn't the average. Where is the average? It's at 2, isn't it? What does this 20 represent?
Range.
No, the range was 200.
Mean deviation.
Yeah, this number here is on average how far each point is from the average.
100 is too far.
Yeah? What's your question?
Is it every point?
Yeah?
Yeah, every point, so it's not.
So 100 is not every.
The 100 is included.
Even 1000 is included.
Well, not on this one, but my point is these distances 100, 100, 4 and 4, whatever. What I'm saying is on average the points are 20 units away from 2. Now, most of the time they're less than 20 units away, right? But some of the time it's more than 20 away. In what cases are they more than 20 away? 100 and minus 100. Anyways, we need some way to measure how far away or how spread out our data is compared to the average. So the idea is we have our data, if you want to picture it like this, and there's a center called the mean average, and the data is all around the center. Yes? And we would like to know what is the average distance our points are from the center. On average, how far away are they from the center? So here's a simple example. 2, 2, 2. What's the average here? 2. How far away is each point from the average? 0. They all are the average. So, yeah.
How can we choose the center?
It's the average.
The average, okay.
Yeah. So, this data looks like this. It's just a point at 2. Now, what about data like this? Minus 100, 0, and 100. What's the average? It's 0. But our data points are either 100 away, 100 away, or at 0.
The what? The data?
The data is either 100 away,
Or
100 away, or 0. It's at the average. So what's the average of 100, 0, and 100? That's
10 or 100.
That's 100 there. It's 33.3, isn't it? 200 divided by 3. No, 66. 200 divided by 3?
Yeah, 60, 50.
67, yeah.
Yes.
So which data is more spread out? 2222 or minus 100, 0 or 100? That's more spread out. So we need to way to measure how spread out the data is. So that gives us our definition. We use something called the standard deviation. And the formula is the distance between each data point and the average squared divided by how many points we have. This is the standard deviation. So let's take an example.
Can I see that again?
The distance between each data point and the average, the mean average, squared, this distance squared, totaled and divided by n.
What's the n?
How many number of points? Yeah. Let's have an example. So here's our first example. So let's say we have the data -2, -1, 0, 1, 2. Keep it easy. What's the average of this? It's 0. So the formula is standard deviation is square root -2 minus 0. What's that? It's -2 minus 0 squared plus -1 minus 0 squared plus, yeah?
The first minus average.
Yeah. 0 minus 0 squared plus 1 minus 0 squared plus 2 minus 0 squared all over 5. Yeah? Right, let's calculate that. Square root 4 plus 1 plus 0 plus 1 plus 4 over 5. Where's my pen gone? Yeah. So that would be 8, 9, 10. That would be square root 10 over 5, which is 1.41. What does this 1.41 represent? Well, it's not quite the same thing as what we were talking about earlier, but it's nearly the same thing. That if you were to look at the distances here, how far away is -2 from the average? 2. And this one, 1. And this one, 0. And this one, 1. And this one, 2. So what's the total here? It's 6 altogether, isn't it? 1, 2, 3, 4, 5, 6. And how many numbers do we have? 5. So what is the average here? The average distance from the center is 1.2. Now I know that's not quite the same as this, but in fact it's pretty close. So this standard deviation, this calculation, what it represents is the standard deviation is roughly the mean average distance from the center, which is also the mean average. So if you want to picture it graphically, you have the average in the middle, and you have your data, and this sigma, the standard deviation, that's roughly the average distance from the center of the data. That's what it represents, that's what it means. So if the standard deviation is bigger, what does that mean for your data? It's more spread out. That the distance from the center is bigger for more of the points.
But Stephen,
Yeah.
we need for what? For this one. It's the same average.
What is?
So the mean average distance is the same with the center deviation.
Yeah. No, the mean average or?
The average, okay.
Yeah.
It's the same with what we are doing now.
I'm not sure what your question is. What are you asking me? The standard deviation?
Yeah, okay.
Yeah, the standard deviation is the same roughly as the mean average distance from the centre.
Okay, so that's what used for what?
What's the use for?
Yeah.
How spread out the data is. So for example, let me give you an example, since now we want to know why we care about this.
What?
Yeah, why? But let me show you why. That's right. I'll give you an example.
Why do you want to put?
I'll give you a physics example. Okay, we got this pad open, this spreadsheet open. Okay. Cancel. Right, calculate. So you remember in physics, put the phone away. You remember in physics you have to collect measurements. You do an experiment and you measure something. So for example, let's say we're measuring, I don't know, the time for the pendulum in seconds. Yeah? So you let the pendulum swing, let's say the pendulum is 1 meter long, and there's the calculator there. Where's mine gone? I won't put in a realistic number. Next. So you let a 1 meter pendulum swing 10 times, and the time it should take is 20 seconds. Okay, so let's say it takes 20.5. Now you do the experiment again. Will it take 20.5 the next time? No. Well, it might take something like 20.2 or 19.9 or 20.6 or whatever. It's not exactly the same each time. Yeah? So let's say this is, I don't know, Fahad's experiment, and then Karar did it, and let's say the first time you did it, it was 21, then 23, then minus 17, no sorry, not minus 17, 17, and then 19. Yeah, that'd be quite bad. Right, so this experiment, you did it 4 times, and the average time was 20.3 seconds. And then when whoever, KJ, did it, he got 20 seconds. Now, which one is better? Well, you would think, but not really. What's the difference between the two sets of data? True, the average is closer to the true value, but when you look at the experiment, one should look better than the other. Which is better?
Oh, this one because that's 6 months.
There's less difference, right?
It's more accurate.
Yeah, well, this is the standard deviation. The standard deviation is, on average, how far away are you from the average? If I calculate the standard deviation here, I think it's this function, I'm not sure. No, let me just calculate it. Standard deviation. STDEV. Okay. The standard deviation here is 0.31. That means, on average, the distance from each experiment with the average is 0.3. Whereas with this one, have a look at the data. What do you think the standard deviation might be? In other words, on average, how far away is he from the average, which is 20? 1, I think it'd be a bit more than 1, because you have a 21, a 23, a 19, and a 17. So maybe more like a 2. Okay? 2.6. Standard deviation is the same thing as uncertainty. Remember uncertainty? Yeah, standard deviation is also the same thing as what do we call it? We call it in chemistry with the darts accuracy, isn't it? Or precision, which is it?
Literature? Precise?
Yeah, precise. Precise is the one where you accuracy. Accuracy is the one about how spread out the darts are from the centre of the dartboard.
Accuracy is how accurate your value is.
No, don't use the same word to explain a word. Do you remember with the dartboard? Here's the centre. So if I'm like this, they're all close together, but fairly far away from the centre. Is that accurate or precise? Isn't this the word you have? Isn't it?
Yeah.
Accurate, precise.
Mm-hmm.
Yeah, which is it?
Which one?
The red ones. This is what you got, but this is the true value. So is this accurate or precise?
You don't say that.
Accurate.
You don't.
Well, what's the word you use then?
Accurate, precise.
Yeah, what word do you use to describe this?
Accurate. It's close to the answer. Precise is when you get.
Oh my goodness. This is terrible. You did this with me and Lorraine, didn't you? Didn't you do a lab report as well recently?
Yeah.
Yeah. Like
But
last
you-
year.
Look, here, I'll show you the picture, if I have it. Do I have the picture? I forgot. The memories are fading.
You're not sure what you're trying to say.
I'll show you a picture. There's a picture here, I'm sure. When I show you the picture, if I have it in this one. I got the picture here. Let me see. I'll just type in accurate. Whoa. Yeah, we've got it for sure.
No.
Accuracy then. Accuracy. Where's the word accuracy here on this page? Whoop.
The closeness of
Accuracy is the closeness of agreement between a measured value and the true value. So here, was this result accurate or not? Well, no, it's not. This is quite a big gap. So this one here we say is not accurate. Because the value you got and the true value are quite different. Yeah, and then we have, but you did this with Lorraine, with the dartboard, remember?
We did.
What?
I think.
No, you did. Oh my goodness, you did. Just like you did proton and neutron is in the nucleus. You did do this. Error is the difference between a measurement and the true value. Okay, no, that's not the one I want. Well, I don't think I can find it. Maybe it's not in this one. Yeah, precision. Here we go. Precision is the closeness of agreement between independent measurements. So precision is how big these measurements are. So if you have something, I can't believe I'm doing this again with you. So here's our true value, and in red, this is precise because these values are close together, but it is not accurate. What about this one? In blue. This one is accurate because it's near the true value, but it's not precise because it's quite spread out. So standard deviation is a way to measure how precise our data is. So here, which data is more precise, the first or the second? The first, because the standard deviation is quite small, these are close together. These ones here, is this precise? No, because it's more spread out. But which is more accurate? Yeah, this one. So this one here is more accurate because, this one here on the right is more accurate. Why? because the answer he got is closer to the true answer. So this one's accurate, this one's not. However, this one is more precise because his answers are closer together, and this one here is not. So standard deviation is a way to measure how precise your data is in a physics experiment. Now you did this with me, and you did it with Lorraine. I know for a fact you did this with Lorraine, because I've seen her notes, and we talk. So I know you did this with Lorraine. Are you saying that you don't remember any of this?
No.
You do remember it.
But we have different lab reports.
Doesn't matter, you should know the words accuracy and
We
precision.
know, like, accuracy.
You did a terrible job of convincing me that you know it. Right, anyways.
But you're asking in different way, like, this is accurate, this is precise.
Wait, sorry, hang on. This is accurate. Lorraine asks it a different way. Let me see, how could she ask it? Accurate, yes or no? No, not this.
It's like this. Is this answer accurate? No,
Yeah.
it's not.
That's what, but I didn't get
This is accurate, it's precise.
this here. Not precise,
No.
because it's spread out.
Yeah.
Yeah.
That's point is out.
Yeah, so it's not precise. What about this? Precise or not precise?
I know.
Which? Tell me.
Precise.
Thank you. That's what I wanted. That's what I wanted. Never mind. Okay, so there is another way to calculate standard deviation, a quicker way to calculate it. I want to show you another formula. So another way to calculate standard deviation is from this formula. I'll explain how to use it now. So this part here means square the data
So this,
and then get the mean.
this square and the deviation.
Yeah, that's right, yeah. Yeah. And this one here means get the mean and then square the answer. Now it's a little bit quicker to do. I'll show you how to use it.
Why did you put inequality?
No, it's a symbol that means average. It's not inequality. Okay, did you write that formula down? So let me give you an example. Okay, so we have the numbers. Maybe we should use numbers we had earlier. So I'll go to the spreadsheet here. What was my first example I gave you for calculating the average? The one we had a moment ago.
420.
It was -2, -1, 0, 1, 2.
Yes.
That one.
Yeah, so let's use that one as an example, okay? Okay, so the first one, this is x, -2, -1, 0, 0, 1, 2. Right, so if you look at the formula, what do you need to do first? Square the data and get the mean. Okay, so let's do that. -2 squared, 4, 1, 0, 1, 4. Get the average there.
What?
Get the average, the mean average.
2.
Is it?
Zero.
No, it's not 0. It's 2.
Average
Yeah.
of what?
Oh, the average of the thing I asked you to get the average of. This thing right here in bold. Look, you probably can't see.
4 plus 1 is 5, then 5 plus 5 is 10, 10
Wait, slow down there, you're going too fast for him. There now. Can you see that?
Yes.
Right, so the average here is 2. So if you go back, that's, this here is 2. Okay.
Okay.
Now, yeah, what's the next part? Get the mean and square it. Right, so what's the mean here? What's the average of these?
0.
That one is 0. We calculated earlier, isn't it?
Yeah.
So I'll just write it to the right here, 0. Then what's next? So the next one here is 0. No, what's next? Then you do 2 minus 0. So that is equal to 2. Yes? Then what's next? So now you have standard deviation squared equals 2. So what's standard deviation? Root of 2. Which is the same answer. So this method works the same way. You get the same answer. But it's quicker to do. Let's do another example. Alright, so example here. X, and then we need an x squared. So let's say we have 5, 6, 1, 2, 3, and 4. Okay, what do I do first? You square it. So what are the squares here? 25, 36, 1, 4, 9, and 16. Then what do you do? Get the average of these. The mean average. You get 15. Yeah. Then what's next? Get the average of these numbers. Now the average of those numbers is 3.5. But then, what do you have to do next? Says it here. Get the mean and square the answer. So, where's 3.5 squared then? And that is, 12.5. Then what do you do? 12.25. And then, the bigger number minus the smaller number. And you get 2.9. Is that finished? No. That's for sigma squared. So then what's next? Square root. So if you square root this answer, now you have the standard deviation. 1.7. I can check in the computer program standard deviation of my data. No, a bit different. Now actually that's because I'm using the wrong function. Standard, no, it's STD, no. It is standard, no, this one, standard deviation dot P. There we go, same answer. So this method is quicker because all you really have to do is square and average and square. So you can do it a lot faster this way. In the exam, you don't mind which method you use, but they're expecting you to use this method though. Okay? Say again? Short, well, in the exam, the questions will be like... It'd be questions like 1, 2, 3. They give you data and they ask you for the standard deviation. Yeah? The other questions here I won't cover because for the engineering question on this topic, the most that they'll ask you to do is calculate the standard deviation of a list of numbers. That's what you do in physics. Although in physics you didn't quite calculate the standard deviation, what did you calculate? The residuals.
Yeah.
So, Karar, another thing that's like the standard deviation. Do you remember when you calculated the residuals?
Yeah.
And you got the average of the residuals? That's the same thing as the standard deviation. It's nearly the same. So you see standard deviation, you can think about it in many ways. In physics you can think about it as the average residual. You can also think about it as the average distance from the center of the data. You can also think about it as how precise your data is, if it's spread out or close together. So we have many ways to think about it. And you have two formulas that give you the same answer for calculating it. Yeah. So, what I want you to do I would like you to do question 1 and 2 now, but I want you to use the first formula I gave you for number 1 and the second formula on number 2 to practice. This formula is in the formula book, however, it's written differently to how I wrote it, and only the second formula is in the book, not the first formula. This one's not in the book. The second one I gave you is in the book, but they write it differently. Let me just show you how they write it in the formula book. They write in the formula book like this: standard deviation equals square root, add up the x's squared divided by n, minus add up the x divided by n squared. You see the difference? It's not as neat as writing it like this. When I write this symbol, it means average of the data squared. And then when I write this symbol, it means the data average, then squared. Now it's the same thing, but it's written in a different way, but it means the same thing.
But you can understand from document.
You can understand, yeah. But I'm saying, if you're asking me, is it in the formula book? It kind of is. It's written differently, and only the second formula, not the first formula. So question 1, use the first formula. Question 2, use the second formula, and then we'll go on to the next lesson. Do you need to write this down? Yeah. If I'm being really strict about it, I should put little I's here, because it's from 1 to n. I'm sorry, but that is the way it will be in the exam. This is normally a section A question. Can I close this, Tekken? Yeah.